Today we're going to start Chapter 7. The unit of study is trigonometric functions. To begin with, trigonometry comes from two Greek words, trigonometron, which means triangle measurement. Ancient Egyptians would use triangle measurements in trigonometry to survey the land. Today, trigonometry is used for much more applications such as radio waves and sound waves. In an angle, you have what we call the initial side. That's the side that you start with. Then you have what we call the terminal side, and that's the side that you end with. When we do not know the degree of an angle, we can label it with theta. And what theta is, it's a Greek symbol. It's a circle with a line through it. And that brings us to some other definitions. First off, we have the definition of an angle. What an angle is the point from a rotation or from a point. Right? Most of you would know what an angle is from geometry class. You can measure angles in degrees, so I can have an acute angle, which measures less than 90 degrees, or I can have an obtuse angle, which measures more than 90 degrees. We have the word revolution, right, which is a unit used to measure very large angles. For example, if I want to talk about the degree that a car tire rotates, instead of talking about degrees, I could say it rotates 3 times or 3 revolutions. A degree is a common unit for a small angle. And then one conversion factor that you should know is that 1 revolution is equal to 360 degrees. Right? So if I go 1 full circle, right, that's 1 revolution, or I could say it's 360 degrees. And then we can get more specific. We can then start talking about minutes and seconds. Right? 1 degree is equal to 60 minutes, and you can convert minutes to seconds. 1 minute is equal to 60 seconds. Therefore, if you take 60 times 60, you get 1 degree is equal to 3,600 seconds. Okay. First example, we are going to convert some degrees, minutes, and seconds to a decimal degree. Right? To do this, first off, you keep the whole degree as it is. So I'm going to keep it as 24 degrees. Then I have 18 minutes. So 18 minutes, well, there is 60 minutes per degree. So I have 18 out of 60. And then I have 20 seconds, and there is 3,600 seconds per degree. So I have 20 out of 3,600. If I add these together, I will get the decimal 24.305 degrees. So I have converted my minutes and seconds to decimal degrees. The next example, we are going to convert to degree, minute, seconds. So we can abbreviate with DMS. Given that I have 19.7 seconds, I want to know how many minutes and seconds are in there. To do so, you take your decimal, which is 0.7, and you multiply that by 60. I keep the 19 as my whole number, as is, but I take my decimal 0.7 and I times it by 60. When I do that, I get 42. So I have 19 degrees and 42 minutes. So, to remember, you always multiply the decimal by 60. Then that brings us to the next definition. We need to know what a central angle is. A central angle is from the center of a circle, right, and it's vertex of the angle. So, looking at this picture, angle NPM is a central angle. It starts from the center of the circle, right? Another definition we have here is the word arc. An arc is a portion of the outside of the circle. In this picture, N to M is an arc that is intercepted by the angle NPM. what we will learn eventually is how to measure the length of an arc on a circle. The next thing is what we're going to talk about is called a radian measure. For most of you, this will be something that's a new topic, right? The radian measure, it's the number of radius units in the length of an arc intersected by a central angle. You can measure an angle in degrees, or you can measure an angle with a radian measurement, right? The degree is the amount of turn, whereas a radian measurement is the length as you turn. So once again, degree is the amount that you turn as you go around a circle, but the radian measurement is the length that you rotate as you go around the circle. Some abbreviations and some symbols are, first off, we have S, which is arc length, R is the radius, and theta is the angle measurement in radians. So when I see this arc length formula, I need to remember that theta is measured in radians, not degrees. I can convert this formula. If I were to take S equals R theta and divide both sides by R, I would then have theta equals S over R. So both of these formulas are useful depending on what you're trying to find. If I am trying to find arc length, I will use S equals R theta. If I'm trying to find the radian measurement, I will use theta equals S over R. So remember, the circumference of a circle, we learned in geometry class, is C equals 2 pi r. So 2 times pi times the radius. Or I can use C equals d times pi, which is your diameter times the radius. So here, the r represents radius, and in this formula, the d is your diameter. Now we can talk about radian degree measures. We're referring to a unit circle, right? A unit circle is a circle with a radius of 1 unit. So 1 revolution in radians is equal to 2 pi. That is a conversion factor that we need to remember. We already discussed that 1 revolution is equal to 360 degrees also. All right? So with those two pieces of information, we can put those together and we know that 2 pi radians is equal to 360 degrees. Or if we divide by 2, we know that just pi radians is equal to 180 degrees. So in a picture, if I have a circle, I know that full circle is 1 revolution, which is equal to 360 degrees, which is equal to 2 pi radians. My conversion factors, then, if I want to convert from radians to degrees or degrees to radians, I can convert radians to degrees by using 180 over pi. I can convert degrees to radians by using pi over 180. And that brings us to our next example. We're going to convert 190 degrees to a radian measurement. So to begin, I'm going to take my 190 degrees and I'm going to times it by the conversion factor pi over 180. So I get 190 pi over 180. But then I need to reduce, right? As long as the directions do not say any otherwise, you can use a decimal. So if I take 190 pi divided by 180, you would get 3.31 radians. Now, it is not necessary to label radians because you can assume it's a radian measurement if there is no degree symbol. So if there's a degree symbol, we know it's degrees. If there is no degree symbol, we know that it's radian measurements. For the next problem, we're going to convert 240 degrees into radians. This time it says leave in terms of pi, so that means no decimal. So I'm going to times this by pi over 180, which gives me 240 pi over 180. But then I can reduce that. 240 divided by 180 reduces to 4/3, so I have 4 pi over 3. And note, this time I left it as a reduced fraction because the directions say leave in terms of pi, no decimal. For example 5, now we're going to go in the opposite direction. This time I'm going to convert to degrees. So I'm going to take my radian measurement, times that by 180 over pi. And again, the directions do not say leave in terms of pi, and there was a decimal to begin with, so I know I can have a decimal in my answer. If I multiply everything out, I should get 149 degrees. When you use your calculators, make sure you use the pi key on your calculator. If you round to 3.14 on your calculator, you will not get the exact answer. So be sure to use the pi key on your calculator. The sixth example, we have a radian measurement and then we want minutes in seconds. So first off, I know I want a degree, so I'm going to convert to degrees first. So I'm going to take my radian measurement, times that by 180 over pi, my conversion factor. That gives me 246 degrees, 0.37. Now, this is a decimal degree, but I want minutes in seconds. So what I do is I take my decimal, 0.37, times it by 60, and that gives me 22.2. The 22 is my minutes. To get my seconds though, I need to take that second decimal right here, my 0.2, and times that by 60 as well. And that will give me 12. These are my seconds. So my answer, if I put all of this together, I have 246 degrees, 22 minutes, and 12 seconds. And there is my answer. I got my degrees when I did the conversion factor. I got my minutes when I times my first decimal by 60. And I got my seconds when I times my second decimal by 60 again. Some commonly used measurements that we should start to remember. First off, you want to remember that 90 degrees is equal to pi over 2. And this comes from the conversion factor that we know 360 is equal to 2 pi. If I divide 360 by 2 and 2 pi by 2, I knew 180 was equal to pi. So if I divide that by 2, I get 190 equals pi over 2. If I divide 90 by 2, I get 45. And if I take pi over 2 divided by 2, I get pi over 4. And then I can convert again 60 to pi over 3 and 30 to pi over 6. These are some commonly used radian measurements that you will remember by the end of the unit. The next thing we need to talk about is standard position. What standard position is when the vertex is at the origin. So 0, 0. The initial ray on a positive x-axis as well. So on the xy axis, you have quadrants 1, 2, 3, and 4. Here is your origin. The initial side of an angle always starts on the positive x-axis. As I move my way around counterclockwise, I have a positive angle. In this example, my terminal side is landing in quadrant 4. I did go counterclockwise, right? So I have a quadrant 4 angle. For example 7, we are going to draw an angle, and it says to draw an angle that is negative 2 pi over 3. Now, for most of us, we are not very familiar with radians. So what we can do is we can take 2 pi over 3 and convert it to degrees. If I times that by 180 over pi, what happens is my pi unit cancels. 2 times 180 would be 360. Divide that by 3 though, I get 120 degrees. Most of us now know where 120 degrees is. Starting on the positive